and under pressure to this policy brief with 5 main recommendations. And I think that's a big achievement. So I think it's nice to discuss the 5 recommendations, and we have 5 speakers. Coincidence, every speaker is going to introduce one of the recommendations briefly. Kathy is going to start with metadata.
Okay, so let's see what recommendations I found for metadata. I'm going to start with a short thing. What is metadata? The project overview, I think you can see what's in there. I will focus on the insights. Let's see what we have there. And when I need, why do I always have this page in front of where I'm trying to look?
Yeah, unclick now the space bar.
Okay, that is your trick. Okay, so I mean, metadata is essential to find data, understand data, use data. Management is still a serious issue all over. It's even recognized, acknowledged by the Data Act. It's often lost in translation between all sorts of different structures. I have my structure, you have your structure. There's no way from here to there. It really must address the needs of both commercial and open data alike. And it requires some serious contributions by the data creators and editors, and pushing all of that burden to the data user. Not only is it unfair, he can't do it. He doesn't know what.
Why is this?
Okay, this is what I'm affecting, and this is pointing out. I mean, we all talk about metadata. We all think we know what we are talking about when we say metadata. And there are so many different things packed under metadata. That is a seriously overloaded topic. Usually when we talk about metadata, we are talking about discovery metadata. This is just a quick dump from Wikipedia. What types of metadata does it be? And I mean, what we have is mostly the descriptive metadata. Structural metadata I have rarely seen anywhere. It's occasionally within the APIs, but to know what type of data model you're getting off of that, no chance. Administrative data metadata tends to be there a bit. Reference metadata tends to be very poor and down to keywords. Process metadata is relegated to prose or nothing, and we do sometimes have copyright and license. We've got all sorts of diverse standards. So, I mean, between our 4 projects, we basically have 3 to 4 different metadata systems. Shows you exactly the problem we have. And the Eclipse federated catalog, is that based on any of these, or is that another one?
Oh, Eclipse, the catalog is completely agnostic when you put any kind of metadata.
Okay, so there we can take the other 4, put them in Blender, and something.
Yeah.
And I mean, each standard is valuable in its context, its community. But how do we attain some sort of interoperability between all of this? We will need some sort of brokers, which are not going to work if the systems are structured too different. If we have 2 different cardinalities, it's not going to work. So we may need to have some core concepts. What do we really need to maintain this type of transformability? On semantic, very often it's just down to free text keywords. There's no reference to an underlying vocabulary. This leads to absolute confusion. You've got different spellings, people misspell it, and then you've got synonyms, acronyms for it. It is very hard to really find. And the semantics point we have on metadata is, please, if possible, don't just use free text. Provide references with a URI to a really defined concept. And where full URIs aren't available, at least try and reference what vocabulary you have taken this talk from. It requires a lot of guidance. And so, I mean, it's partially which metadata standard is most relevant for the community, but also which resources should we use to annotate things. And this is one example which had just come over my desk and it left me stunned, and therefore I want to stun you all. This comes from our metadata catalog, and we have this pull down list which license, and I could never find the bottom. And I finally got the full list. It comes from SPDX. There are only 648 different licenses there. And I mean, these screenshots are just a tiny little subset of that. I'm sure that most of them overlap because there are only so many different concepts you can pack into a license. I'm sure we've got all sorts of duplicates, triplicates here. But this does not make anybody's life bearable who is trying to look for a license. Will the true license please stand up? And I mean, the same also goes for species lists or the like. And if we can all agree on one vocabulary we use for a topic, it is much more likely that we can cross-map this than if I use my vocabulary, you use your vocabulary, we're at the same place we started at. Additional requirements. So, I mean, if on the one hand, everybody is complaining, this is way too much work already, and I should do this work for all the metadata. At the same time, we've realized there's quite a few relevant bits which aren't really being covered well by a lot of metadatabases. And I mean, it starts with a topic very close to my heart, observational metadata. In the observations, measurements, and sample standard, we have nicely described everything about a measurement. This never gets up into the metadata systems. So at a metadata level, if you're lucky, you've got keywords which give you the observable properties. Everything else is lost. That needs to go up there. Continuing on with the observable properties, here it'd also be valuable to integrate the atomization that Barbara showed this morning from IADOPT of really splitting this into the individual subconcepts. That could also be relevant at the metadata level. A further thing which I also haven't been aware of until recently is actually the ISO 131 data product specification standard, which is very parallel to metadata and 115. But it does have quite a few additional concepts which are, again, valuable. We would need them. And finally, also data provenance. I know there's some basic support for it in 115, but it still tends to have various gaps. And what I've been missing everywhere is proper descriptions of the processing that actually apply. One thing we try to do in FAIRiCUBE is all the metadata to describe the processing routines, and then we can say, this data set was generated from these input data sets with this processing routine. That is fairly clear what we've done. Resources. And I mean, the core thing is that all data management and metadata creation, nobody wants to do this. Yes, we have to do it because somebody says so. And you push it off to the bitter end, and then we don't have time anymore. And next question, please. And I mean, it tends to require more effort than expected. You think, okay, I'm done with my data. I will spend 5 minutes on the metadata, and a day later, you are still scratching on it. So you really need to foresee that in advance. It should be defined at the start of the project and start writing what you are doing as you do it. Then you don't have the excess burden at the end. But we'd also really welcome if European project goals would be stricter on requiring the necessary resources, both for data management, but also for metadata creation, and then also for data persistence. And finally, provide recognition for good data creation. The world is being more and more split into different tasks. You've got people who spend all of their time creating the data, and they don't have a career. They're just fools who do that. So maybe we could get more data citations so that these people really get recognized for the hard work they've done. Pipeline and user friendliness. So, I mean, within FAIRiCUBE, we tried to set up a pipeline to get that sort of clear. We nailed down 84 metadata fields, of which 30 are mandatory. It's so much easier to describe your own data than trying to figure out somebody else's data. So, I mean, we have quite a bit of our data fairly well described. That's it.
I will talk a little bit again on this topic after giving you the demo. So I think it was supposed to be reversed, but okay. So anyway, I think it's unnecessary to expand too much here again and too many details. We can have more discussion later on. So this is our approach in AD4GD, as you have seen in the presentation of the demonstrations. Of course, this is not important about the Gradle data space. Just to say that in AD4GD, one of the main aspects that we are dealing is about interoperability. That was from the very beginning the conception of the project, interoperability, especially at the semantic level, was one of the main aspects that we were going to be addressing. So, well, basically, first of all, regarding the approach in AD4GD, following also some kind of examples, best practices, experiences from other projects, we at the end come with this incremental approach. Basically, it means that it doesn't. We are not requiring or forcing everybody to have like complete semantic interoperability at the very beginning, because we don't want to let's say limit the kind of assets and products that we can have in the data space. So we need to be quite open. So as long as people is coming, of course, this is step one. Of course, we can go then, more incremental in the level of interoperability, how the assets can be more interoperable, increasing their level, similar to what is, the 5-star rating schemes from Tim Berners-Lee. So in general, the approach is based on 3 main components or building blocks. One is, the use of common information models. So that comes, ontologies, taxonomies, control vocabularies, etc. So in this respect, we are mainly talking about here of the Green Deal information model. I will talk about this in a moment. And also, of course, vocabulary servers. In this case, we are using OGC Rainbow as a vocabulary server for the presentation of all the different semantic artifacts that we are creating. Then the other component is about the components that are producing and consuming exchange data. So how we can generate data that is harmonized according to those models. And that's what we call the pipelines, which has some similar, conceptually of also what was mentioned before about the recipes. It's basically a pipeline, tells you how the process goes for the harmonization of the data itself. And the third component is about the provision of APIs, standard APIs as much as possible. So the Green Deal information model is based on, different existing standards. We are not creating anything from scratch here. And the idea of this is to create like the core building block for this common Green Deal data space that will enable in different systems to interoperate and exchange data, and also the analysis of data coming from different systems in an integrated way. But the model is modular, is following also like a layer approach, and is reusing some of the architecture and high-level layers from something that we did in the past, which was called the agriculture information model, which actually is also, in the process of OGC becoming some kind of a standardized model as well. So as you can see, there are different layers. You have the core layer where allow you to do mapping with different building blocks, models. Then you have the cross-domain layer, which is actually providing like these different elements that are necessary to represent information that can be applicable to multiple domains. For example, measurements and observation. That is something that very important. Time information, units of measurement, statistical information, etc. Then the main information, domain-specific information. So here we come also trying to reuse as much as possible whatever is available, from vocabularies and ontologies like, SAREF, smart data models, and some others. Then we also have, the metadata layer, which is providing all the kind of terms and elements that we can use in AD4GD in order to describe resources. To be honest, that wasn't really much of our, let's say, focus at the end. The metadata layer, of course, we have it, which is mainly based on DCAT, as you can see, DCAT and extensions. But it's our main focus at the end was more on the data itself, that is going to be structured in more standardized form. But the most important also in this model is that it provides alignments between different concepts in different vocabularies. And this is why then we also are able to represent and use information coming from different sources, because we have this alignment also explicitly in the model. And at the end, of course, we connect to existing vocabularies like, essential variables that we were just talking before. We created some vocabularies in AD4GD for sensors, for observable properties. We realized that they were not enough. For example, the climate and forecast models, observable properties were not specific enough for some of our needs. So we defined, some of those in our own specific vocabulary. And so this is give you an example of some of those. First, the essential variables. We use the essential agriculture variable, the essential biodiversity variables, and essential climate variable. Now, the only thing is that regarding the essential climate biodiversity variables, we did an exercise one step further, and not just to go into semantically representing, but align them with IADOCT, which was presented previously today. I will show you how it looks in a moment. And of course, we also propose the usage of climate and forecast whenever it is possible. But as we saw, and this is kind of lesson learned, the AD4GD pilots were not comfortable enough with those kind of variables that were defined at this level because they were not specific enough. So this is how the essential variables are looking in the OGC Rainbow server. But I have to say that just a few days ago, like last week, there's a new version of the Rainbow server, which is now much nicer. Actually, let me see if I can click here. If this would take, yeah. So this is the new interface of the Rainbow server, where you can see the visualization of the essential biodiversity variable.
But I've read that the nice diagram has gone.
For now, yes, but I know that it's gonna be back soon.
Okay, good.
So
Good.
But I mean, I was talking with OGC guys, and it's gonna be soon back. But at least it's much modern interface than the other one, so it's nicer. Yeah. So, and this is aligned with IADOCT, as I mentioned before. So similar approach is in other domains have been taken, of course. In ILIAD, for example, we did similar exercise for the ocean domain. In the Meter, and now also OpenAgri, it's our other projects related to agriculture. We have similar approaches in terms of the models. And then, of course, the tooling, right? So the technological support. So this is what we call the data harmonization pipelines. As you can see, there are many different steps that are necessary to go from the source data into harmonized data. So you specify some kind of pre-processing steps. Let's say you need to specify how to do the mapping itself. You need to do the transformation. Then you need to store somewhere the results, etc. So all of these steps are what the pipelines are doing for you. And the idea for us is to make this as automatized as possible, so that the pipeline is defined once, and then you can reuse it whenever new data comes just by changing the input data. And that's how I show you in the demo. This is how it works, right, in practice. So this is just giving you some of the interfaces to use the pipeline. So basically, as I mentioned, there is a command line tool. We use this command line tool also, for example, in HPC environments when we have huge amounts of data and we wanted to do all this harmonization. So the command line tool is quite useful for that. But we also have like a RESTful web service. We have the web client application. And in terms of how to specify the mappings, there are different ways. Like I show you YAML, but there is also something that is called YARM. There is a Sparkle. You have CSW, CSBW. There are different ways of specifying the mappings, right? And like I said before, this is what we are trying to facilitate with the use of LLMs. And the last thing is these APIs, right? So how a different component normally implement different APIs. So this proposition or idea is to try to come as much as possible also with standard APIs. And the good thing about this is we can actually generate those APIs automatically because we have data harmonized. So if we know how is the data harmonized, all of these APIs can be easily implemented. And this is where I show you in practice the OGC Internet of Things API generation service, which enable access to link data about observations that is in some semantic database. That means like a Sparkle endpoint. And then you just say, okay, this is my graph. The graph is like a table. Let's say in the semantic database is the table. Here is your data. This is like harmonized according to our model that we SOSA SSN for the measurements and observation. But just give me this the Central Things API, and this automatically generates these endpoints for you. But of course, there are other interfaces to access harmonized data. The faceted browser. You can create custom REST API on the fly, based also on SPARQL queries, which give you a very powerful query language, and that can be exposed as a REST API. There are applications that we use in for example, in Iliad, we use a lot of dashboards to show the harmonized data on maps, on graphics, and so on for insights. And yeah, so this is what I show you in the demos of the general architecture of AD for GD and the instantiation for pilot 1, how this was done to carry out the harmonization and enable the semantic interoperability. So yeah, that's it from my side.
Good afternoon to everyone. So just for the usage project, we will have an overview of the data ingestion and harmonization, the Spire harmonization process we followed for the use case of Ferrara, in particular for the Natural Historic Museum of Ferrara. So we will have an overview in general of the Spire harmonization process and the specific workflow we followed for this use case and the main steps we performed. So regarding the Spire data harmonization process, we can schematize in these, let's say, several steps, starting from the data model analysis. So in this step, it is necessary to analyze the source data model and the target data model that in this case is Spire. Sometimes in this process, several experts are involved because sometimes let's say the thematic expert does not know the Spire data model very well, and on the contrary, let's say the Spire expert needs the support of the thematic expert to understand the source dataset and the source data model. Then there is a matching process phase in which you need to identify all the information contained in the source data model and the correspondence with the Spire data model. And this step is useful. Are useful the Spire mapping table that there are simple Excel tables that allows you to document this matching between the source and the target data model. Then there is a transformation phase that can be done with an ETL software, like for instance, Sales Studio that we used, or FME or other tools that allows you to, according to the mapping done in the step before, you can transform your source dataset and derive the Spire compliant general dataset. Then an important step is the creation of the metadata. For both dataset and service, even if so, and in this case we use a GeoNetwork, but okay, there are other tools to publish the metadata. In this step, so there is a simplification in the Spire community about, for instance, the service metadata. Because, for instance, you are not obliged to create the standalone service metadata, so the ISO XML metadata for the services, because you can. There is a good practice about the simplification. For instance, you can in which there is a mapping between the service metadata elements and the service capability elements, for instance, of the WMS, WMFS, Atom, and so on. So you can avoid the creation of the service metadata if you follow this good practice. You can document the service metadata inside, embedded, let's say, in the capability of the network services, and for sure insert in the dataset metadata the link to the the link to this to the endpoint of the related service. And for instance, the SPIRE reference validator contain an additional conformance class that checks that you are implementing this, let's say, simplification and this good practice. And then there is the validation process. So I mentioned the SPIRE reference validator. With this tool, you can validate all the resources, the metadata, the data, and the services. And then there is the publication of the harmonized data through the network services. And I want to mention that see, this harmonization process has been adopted only for the usage process for the specific use case of the Museum of Ferrara. For the other use case, the data structure, the data diction, so the documentation of the source, let's say, data model of the use case output data, such as the so-called decision-already information dataset, has been documented in the dataset metadata. In the specific case of the Museum of Ferrara, the workflow can be schematized in this way. So we started to finalize the source data model. They stored for instance, the information about the speech distribution in several Excel files, with many sheets. For instance, where they used one sheet for each species. So there was a huge work of the cleanup of this dataset. In the end, a GeoPackage, let's say, all the dataset, these Excel files were restructured and migrated in a GeoPackage database. Then, okay, there is two blocks on the right. You can see the SPIRE GeoPackage template. So we developed for this data team, in particular for the speech distribution data team, the so-called SPIRE GeoPackage template, following the related SPIRE good practice about the alternative encodings, in this case the GeoPackage. So we followed the rule containing this good practice to develop our database structure that is close to the SPIRE, that can be used as alternative encoding to the official SPIRE and encoding that is the GML. Then we the source dataset, we verified that the source dataset contained more information respect to the one that match with the SPIRE data model. So in any case, they decided to, in any case, migrate their source data in a database close to SPIRE. But in this case, an extension was developed. So starting from the SPIRE GeoPackage template, this structure was extended to contain also additional information contained in the source dataset. Starting from this template, then with an ETL software, in this case AL Studio, we created the SPIRE compliant dataset that can be shared also through, for instance, an Atom service. And the structure, the database structure, in this case, we started from the GeoPackage template, but we migrated this structure in a PostGIS database just to use this source structure for the publication with the GeoServer. So this is the main step. Okay, I already mentioned the work done on the source dataset to optimize it and to clean up this dataset and to create, let's say, a DB structure for this source dataset. Then there was the mapping phase. So this source dataset was mapped with the SPIRE data model. And then there was also an important phase regarding the semantic harmonization of the species nomenclature. In this case, for sure, in their dataset, it was present the name of the species, but sometimes with so you can see, for instance, in this Excel, in this Excel, with some strange characters, with sometimes there was a comment instead of the species name, and we used this tool, the passive taxon match tool, to find a correspondence between the name present in the dataset that you can see in the column A of the Excel and the related, let's say, in this case, you can say the UID, but this corresponds to a link of the eunomen vocabulary. So this tool was able to extract, to find the corresponding between the name present in the source dataset, even if in some cases you can see in this case some question mark additional characters present in the name, but the tool, let's say, was able to identify the speeches and to find the match with the related URL. And we used this Excel then to map the species name present in the source dataset with the corresponding URL of the relevant code list. As I mentioned before, we created the GeoPackage template starting from the Spire data model. This dataset, the source dataset, was ingested in this extended GeoPackage template. And then there was the transformation process using the AL software for the generation of the compliant GMB file. Then there was a publication phase using the usage server instance. You can see in this case a preview, for instance, of the related WMS in this case, but we published also, we pushed the WMS, the GC API features. And as you can see in the screenshot, also the get feature info on the WMS contain the structure of the GeoPackage template. So you can see so we follow some rules to derive the name of the attribute in this flattened structure, because the Spire data model has a nested structure, but there are some rules to derive, let's say, this flat structure of the GeoPackage template. As you can see, so for instance, for these species names, we in the end used the related link to the related vocabulary of the eunomen vocabulary. And then there is also through the usage your network catalog, the publication of the related metadata with the link to the related services. And that's all from my side.
Here you have.
Okay, yeah, that's not it.
Up here.
So, well, here we are. So,
Yeah, dat goed in.
people who know me know that my background is security. And I've been doing this for 15 years, doing security architectures and recommendations and breaking things when someone asks me to do that. So I have seen very many architectures, I've seen very many approaches, how to exchange data. So I'm not a novice in this, but what you guys have been doing in the project is completely, I don't know. So perhaps you tell me, and then I tell you what I think. You do right, you do wrong, or you can discuss among yourselves. How do we do this? I don't know. So adopting and promoting open, easy to use technologies that support seamless integration of both open and protected data. Yeah, of course. Of course. But what exactly do you mean?
How can we allow people who have open data to provide that without all of the excess burden of the connectors? I mean,
You can't. You have to die one or the other way. So open data is open data, and protected data is protected data, and you can't mix those two, period. You can't, you shouldn't.
Why?
Because you cannot separate protected from open once you mix it up. So after that, it's all open. Do you understand that? If you mix open and protected...
No, wait. If Mr. Security had done his job correctly, One could nicely identify which of the available data is to be made openly available and which has all sorts of security concerns.
You think so?
That's what I expect from you.
I would have been a millionaire if I had a solution for that. What I can tell you is that everyone who tried to do exactly that just failed. And if you have a solution that claims they can do that, it's broken the next day. It's hacked the next day. So the question really is it feasible in the first place to come up with something technology-wise that allows you to mix apples and bananas, but still keep apples and bananas separate, so that at the very end of the processing, I can separate the bananas back into the rotten pot and the apples I sell?
Barbara has something to say there.
Why do you need to separate at the end? So I think in some cases, at least, the idea of mixing public data with your private data is to do something, your own use case, your own scenario, whatever. So, you know, you do the mixing, but you can get the data from different sources. And of course, you can work on top of that. At the end, you get to your result. You don't necessarily, depending on the use case, but you don't necessarily need to say, okay, this coming from the public data, this is coming from the private data. Actually, my goal was to mix this because I have some data that is open, some data that is public, and together they give me the full information that I want from my.
So at the end, you have apples and bananas, and you start digging in front of your house, and you break the gas pipeline.
But imagine there is sensor data that is coming from some public sources, and sensor data is coming from your private sensors, and you mix them. It's sensor data. It's not apple and banana. It's sensor data.
It is, from a legal perspective, a dangerous thing. If you have
That
this
is for your
data,
use case.
and you are responsible for it, and you mix other data with it, and at the end you do something with that mixed thing, then who is responsible if something?
But you are responsible. It's your data. It's your private data.
So why do you collect it in the first place? To keep it in your pocket.
Not to mix it with the public. Right?
But then you're not in the data space anymore. Then you're in your private pocket.
For example, but that's or
So you're mixing apples and bananas, and then you make it available as your measure.
It can be my business partner.
Okay, so let's stop this, because we already see that this is not going anywhere. So it is complicated. That's number one. It is complex. So data exchange in data spaces is something that needs to be discussed further. And what needs to be clear is the use case, who is exchanging data with whom, what is the purpose. So all these things need to be clear. And this is a nice wish, but yeah, okay. Okay, next thing. And ensuring the integration of diverse use APIs.
Barbara, do you want to?
Oh, Mark, sorry, you had.
No, Barbara was there. You wanted
Sorry, I wanted just to say, I must apologize. I was not the whole time here because I have another. I don't know how you organize it, but first you have your metadata with the data usage license attached to it, which is the grounding of fair data, and only if it is a license that allows you should get access. But you all can organize.
You can organize access based on licenses? Since when? There are how many million different license types that are not compatible if you don't understand exactly what you are going to do with it? So one example of data exchange and reuse of data based on licenses, I've been to geospatial conferences and fun fairs, fair things. People buying drones to create data, training data for their AI. Everyone is doing that. They're not reusing someone else's training data. They are using their own training data. Why are they not reusing someone else's training data? They can't trust it, and the licensing on it, we don't understand. And if there is an issue with the data, who is liable? So we do our own thing. So everyone acts in his own pot. There is no data exchange on this particular drone thing. So licensing is in your way. Legal aspects are in your way, and you really want to do something with technology that solves all that? Okay, So sorry for being negative, but
That's your view, yeah.
yes,
But you
that's
can
my view.
They can also make it better, right?
Yeah, absolutely. And I'm just want to point out what I think is critical to make this Green Deal data space work. So legal needs to be clear, licensing needs to be clear, ownership needs to be clear, use cases need to be clear. For this one here, you need clear technology space. You need to know, is it going to be online APIs? Is it on the edge? Where is it running? So you need all these different things. So it's very complicated. So ensuring integration of diverse in-use APIs from data providers and user communities into the data space environment, accompanied by demonstrators and clear guidance. Okay, promoting the adoption of standardized APIs to facilitate smoother uptake or instance of OGC APIs for geospatial assets. Okay, someone enlighten me with that one. What do you mean? What do you mean?
The background of this were previous recommendations that the Green Deal data space doesn't need any common models, any common APIs. We've got authentication, problem is solved. And I mean, that we saw yet again in these projects. If we do not have common structures, common ways of accessing this, it's not going to work.
So you have how many years, how many projects, how many techies have tried to solve it, and you have no solution? So how can it be possible at all?
I believe what the mission of these two bullets is to try to say that there is a control plane and there is a data plane. In the data plane, we want to use the APIs that we already know. We don't want any imposed transversal API. I believe that was the intention. It doesn't say control plane or data plane, but I believe that was the intention. We want the data space to be agnostic of the actual API that, in the end, communicates the data.
So you want to reuse APIs and processes and everything that you already have to do something fancy new. Okay, so you basically want to build a car with two wheels without taking off two wheels to make it a motorcycle. So now I'm trying to understand. If you have everything in place and you want to carry on with that, but you want to do new things, where do the new things get bolted on?
Well, in our
There's
absolutely.
so
Yeah, my understanding is correct. So one of the proposed solutions was metadata, right? So this would mean, or the recipes also, right? This would mean that we kind of remove the actual data from data space. We only keep the instructions how to access it, and these instructions are standardized. Okay, and it's completely agnostic of what actually is in the data set. We just leave instructions that, okay, this, I don't know, we have to have some kind of standardized properties of each data set.
I understand.
That's the idea.
Okay, so final question, data exchange. Among whom are you exchanging data? You have no technologies, you have APIs, you have metadata, you have semantics, you have vocabularies, you have licenses, you have agreements, you have contracts. Among whom are you exchanging?
For example, among researchers,
Among researchers,
for example,
okay?
or public and government. Well, statistical division of government.
So you mean between universities. You want to use Eclipse Data Connector to exchange data between universities.
Not only universities.
Public institutions like the Statistical Institute that needs to talk with the forest administration of the same country.
But statistical data is for free, is public data, isn't it?
Not
In risk, yes,
No.
but then
if the Statistical Institute of Luxembourg needs to access the Nature and Forest Administration data, it gets broken because on one side they are not able.
Okay, and you need a data connector to actually download a CSV file that you can do research upon. You cannot simply write them an email and say, "Can you send me this CSV?"
We need some standardized ways because writing emails takes 6 months to get things done. So if there was some standardized ways to get all the administration to get all the
Okay.
how we can have one way to share data.
Would you share the data back to the when you have done something with the data? Would you share that back? Would you exchange it back with the public authorities?
Yeah. Generally, when you do something with something with open data, and you realize, and the data owner realizes that you added value, that's like they was a fact.
Municipalities too.
A very clear example of a problem of the data exchange. From real life situation as a simple person, this is not related to research. I needed to exchange my Georgian driving license to Swiss driving license. Okay, so in order to do that, I had to go to the local office of vehicles. Okay, I made an application. They tell me we need to contact Georgian Ministry of Internal Affairs to confirm that it's really them who issued this driving license. So what they did, they sent an email. I mean, 21st century. Okay. Yeah. Thankfully, and wonderfully, this current government didn't manage to destroy all the epistles in Georgia governmental structures. So instead of 2 weeks, they responded the same day, in several hours. So this was pretty fast. Even Geneva office didn't expect such fast response. Okay, great. But wouldn't it be wonderful to have this data exchange automated? They click request, and the system knows, based on scan of the document, that they have to call an API of that country, which will return, yes, we have this driving license in our database. Done. And that's one of the ideas that this could solve as well. Not only research data.
Okay.
I have another example.
Yes.
Yeah, you asked, probably that was you asking out there about this, the lake water quality or measurement, publicly available or not. Other regions, I know that I'm working on other projects in the Horizon project, but then in Catalonia, depends on what they're measuring, the municipality. They don't want to release water quality, not necessarily to everyone. So we have to make a request because of this research purpose. We need a permission to use this, but that's all the way to do it. Yeah, so I agree with him that we know how to do that, but in a systemized way. But all paperwork, 6 months a month, because we're dealing with the government or the municipality.
So in order to get the government going, what would the government need to do to exchange data with you? Yeah.
So Andreas, I mean, what you're basically trying to say is that the recommendations of these projects is not identifying trust and identity management. Okay, yes. Fine. So we're done. Explore this. The fact of the matter is there is several binders full of information about exactly what you're talking about. It's the ARC blueprint for academic identity management, which is subscribed to, managed in Eurofagel, involves some 9,000 identity providers worldwide, establishes the REPEDS attributes for academic participants in that system. That's academia. You have the world of EIDAS 1 and EIDAS 2, which address personal identifiers for individuals in Europe to the extent that the local country has adopted it. Not all member states have adopted it, and EIDAS 2 has not even begun to be implemented. So there are many gaps there. There are the whole question of corporate and organizational entities, which is addressed in a number of ways. You have to look at the Gaia X specifications, and I realize you don't like Gaia X, but they've addressed this.
Well, that's not true. I think it's overcomplicated.
They've
But
identified a number of trust anchors and trust service providers for organizations. They, in turn, can establish through their own delegated systems and the delegation of authority, if needed, from an organization to an individual to act on behalf of the organization. Whether that works or not, I don't know. In the simple architecture, the simple system, simple open, there's a two-tier system that bridges between individuals and organizations. So all the things that you're talking about are discussed there. They're not solved, but they are discussed there. And they're not in this list of recommendations, that's for sure.
that's why I was after, yes.
So there
That is not
the second issue is exchange. There are two things that can happen with data. It can move from one holder to another holder. And when it does so, the only thing that is allowed to happen is that that stream of bits can appear in the data plane. The infrastructure that is owned and controlled by is the data consumer. And Barbara, your point about licenses doesn't quite get it. You're right. There are licenses, and there's SPDX with 648 different license values there. But what is truly missing is a common vocabulary that could be implemented within ODRL, the Open Digital Rights Language, for data visibility, access, and use. There's work in different domains going on in this. For example, G8 that's the Global Alliance for Genomes and Health, has a thing called the Data Use Ontology, and they are converting that to a format that would be compatible with ODRL, a work in progress. Same is going on in social sciences, same is going on in a number of other areas. These could be the start of some common, what I call a common data visibility, access, and use vocabulary. It's not a policy. Everybody will choose their own, express their own policies using a common vocabulary so that they know what is what and talk to one another. It could be forestry, it could be environmental science, it could be health, it could be clinical genomics, what have you. So another piece, so we've exchanged data, but in fact, you only are allowed to copy it there. Now, the trust framework is the thing that's going to give the data provider the ability, comfort to know that the person who's getting that piece of data is well identified through the identity management system, has the right credentials to get a copy of that data, etc. The next question, which hasn't been addressed, is you touched on it, is how do you combine data? How do I put two pieces of data together? What do I get if I add all of the Copernicus and a bunch of personalized health data?
That was a good basket.
What is the output of that transformation, that combination?
To add then LLMs for this process.
Well, if you add an LLM who is very good, what is artificial intelligence really good at? Finding outliers in data sets, which often are people, if it's out there. So it can identify individuals without it intending to be a re-identification process, but it can be done. So the real question of how you combine open data and non-open data and what is the access and use policy for the result, very good question, unanswered. By anybody, not by these four projects, by anybody.
But
Projects running.
But in AD4GD, we have an example. I mean, like, even if it's, of course, imagine the case of the lakes of Berlin. We have the data of the lakes. At the moment, of course, this is open data, but imagine that this would be for Germany only available. And we have meteorological data. We combine all of those data to do the predictions with machine learning and all other models about, what is going to happen with the lakes. So that's the use case. And this is, combining data from different sources.
So we don't sell the data to your health provider because you're drinking the water from the polluted lake.
Well, I mean, if that was your use case.
I'm finishing up one sentence. Yeah. So one sentence at the end of my presentation, and thank you for participating in it. I hope you learned something. You're not theirs. There are almost more questions than solutions or answers. So the recommendation is we need a follow-up project, at least one, properly funded to deal with those questions, at least for data exchange, that are not fully answered or just people thought about, okay, these are the topics that we need to address. So you guys started walking into a right direction or not? It's not up to me to say, but you're not there yet. So the recommendation should be, we need a follow-up. We need to do more work on this. We have a good idea where it's going, what we need to do now, but we need to do that. So I hope you share that. I hope you share that vision. And sorry for filling this spot. So
No, thank you. It was a good discussion. So that was what we were hoping for. So thank you.
We will send the follow-up.
But we have another
Yes.
topic. Joan, the
Well,
last one.
after the
I think that, good enough.
Do it quickly and nice.
And that is kind of strange what happens, because I was really sure that you will go for the other blue.
no.
That is actually the topic about the alternative architectures and so on. Anyway, it seems that I suddenly became an expert on governance.
You're the boss.
You don't have to. You can do it, you know.
I'm trying to do something original here. But sure. Suddenly I became an expert in governance, and I had to confess something to all of you. I have never read this part in the in the policy brief until, I don't know, 1 hour ago.
Very bad.
So those are my observations to this.
Lara, to know.
I have been reading a little bit, just a little bit, because, as I say, it's not that I'm not an expert. I probably don't care about governance, but that's another thing. I have been reading about the non-technical building blocks of the Data Space Support Center, and in particular the ones that are under the title governance. And what I have discovered is that they have two of them. One that is called Organizational and Governance Authorities. That is mainly a discussion on if we need a legal entity or not for the Green Deal data space. So it talks about authorities, rules, compliance, and resolving conflicts. Then there is another one that is called Participation Management, that talks about rules of onboarding and offboarding, roles that the participants could have, etc. All right. So then I went to Sage, and I didn't even remember the number of the work packets that deal with government. I have to double check. It's number 4, actually. You know your numbers. Well, we have that reasonably covered, in the sense that there is the discussion about the legal entity in the first task. We have the rules of onboarding in the 4th task. And we have something interesting, because I missed something in my description. In my description, under the organizational and governance and authority, there is something about trust and quality data. This is supposed to be dealt by something that we call data governance. That's the task number 3 in that particular work package. It says it shall be based on the needs of the users. Anyway, I went one step back and I saw a little bit of the context of that. And apart from this governance, there are other building blocks about the business of the data space and how this needs to be found and the value added that the data space brings, etc. Okay, now let's compare with what we have in the column. So the first thing that I mark is something that says common good. So nothing about business, it's about the common good. And it talks about dynamics and evolutions of the different aspects. That is, I haven't found anything about dynamics, because what they were after is about the legal, immutable rules on how this is going to work. Anyway, I like this idea of the common good because that expresses a contrast between trying to have a business model, trying to see a business model on the Green Deal data space in terms of how on earth we are going to maintain that if the European Commission doesn't give us extra money to actually continue with that, versus it could be good in itself. So maybe it's not profitable, but it brings a common good, and maybe that's enough. So that I believe it's important, this distinction. So it's clear that in our recommendations, we have a different view. So we are not going about business, we are around common good. And after that, it's not surprising that all the recommendations, 1, 2, 3, 4, 5, 6, 7, almost all of them but one talks about data explicitly. So instead of legal entities and onboarding stuff and so on, we talk about data. The first thing that it talks is about keeping the data in Europe. This is what it says, more or less. I'm just summarizing those. The second one is about the discussion that we had, but in a different orientation, recognizing that there is open data platforms and how we bring those open data platforms into the Green Deal data space. Then there is another recommendation that is the same recommendation, but written in the opposite. It says, does guarantee that it does not become exclusively commercial. That is saying more or less open data again. And then there are other recommendations that go in the line of including best practices on how to manage data in the government itself. So it says, make mandatory citation of the data, providing standard vocabularies and so on, covering the life cycle. I don't see Bente here, but Bente will be very happy to see life cycle because life cycle is data management principles that cover the whole life cycle. I'd say it's data harmonization, semantics, metadata, etc. We have talked a lot about that. And the last one is again the same three, but in the opposite direction. Prevent silos. No? So in the end, I like it. I have to say, I like it because it goes in a different direction of the building blocks. It brings another perspective. It tells that in here, in this community at least, we don't care if the data space will be, the Green Deal data space will be profitable or not. We prefer the common good.
Okay. So what did it find then?
I'm not saying you didn't fight. I say I like it. That would be completely the opposite. But anyway,
The opposite?
you didn't fight, at least from my point of view.
Well, I mean, we went through several rounds of feedback from all projects and just kept distilling, condensing, focusing this, and that's how we came to this. So I do think it is a valid extraction of what the 4 projects have seemed experience.
I have only one last comment. There is no reference on complying with the EU regulation. We have a task 5 about that in Sage, but there is no thing about EU regulation, probably because it's obvious. I mean, you have to comply with the EU regulations or you are not going even to say. So anyway, this is my last comment. So I leave now the discussion.
Yeah. We have 7 minutes, 6 minutes left for the discussion.
All the discussion.
Any questions? Any suggestions? Any remarks?
I'm going to put Andreas back to the front and the discussion goes on.
It's already
I'm surprised Mark isn't pushing back against what Joan said. We always push back.
I mean, we will be disqualified by Sage. No, I mean, let me say something. The composition of Sage is very different from the composition of these projects here. There are many companies in Sage that has a completely different view on how to deal with data, or if you want, how to make a little money with data. And in here, it's a bunch of scientists and technical guys trying to solve the problem. It's different.
Well, I'll say one thing. It was a condition or a piece of the call for the Green Deal data space for it to be sustainable. So in order to be sustainable, there needs to be a way to demonstrate the value proposition. And sometimes that means there's a business model, but it doesn't necessarily mean that there has to be a business model. There are going to be a lot of situations where people are exchanging and combining data amongst themselves to benefit themselves, to learn something about their own little part of the world and say, how can we combine data for our own purposes and learn something better and improve our own performance based on that. So that would enable this shared creation of value without any exchange of money. It's also true that in SAGE, and we haven't discussed this, but everybody here has been talking about geospatial data, but in this, if you look at the 10 use cases in SAGE, they use to varying degrees and as much as 0 geospatial data and as much as 90%. So geospatial data is important, but it's not the only thing in SAGE, in the Green Deal data space. There's a lot of other stuff that is just not geospatial. Doesn't have coordinates. It's supply chain information, it's research information, but it doesn't have a latitude and a longitude associated with it in some way or form. So yes, SAGE needs to figure out how to use this geospatial data and use all the EO and RS data that's out there, but it's not the only thing that needs to be solved. So I think there's going to be a high degree of discussion around public good activities for sure. And part of the value proposition of a lot of these use cases is we're going to improve healthcare, or we're going to improve personal health outcomes because we know better, urban heat islands, that would be good if people weren't dying of heat exhaustion during the summer because it's not properly planned for. But, there's no company that's going to pay for that. So how do we get that paid for is the question. Who is the beneficiary? That does need to be made more explicit. So projects, for example, like usage, identified stakeholders, but how do we get them more engaged down the road to be ongoing participants and ongoing contributors to SAGE to get that result that they want because they need it for their populations? I don't know how to do that, but that's something that SAGE needs to think about. So that's the place where the public good turns into a private value, namely enough to pay for the Green Deal data space. And does the European Union need to continue to pay for that? I don't know. Maybe they just tell Copernicus and Destination Earth, you must make your data available, and EMOT and so on. Keep doing that. Cooperate with SAGE. That may be the public good benefit or the public good input that is necessary to make SAGE work. Or not necessarily a payout. Sorry, Kat.
I'm also seeing, just going back 10, 15 years, what was initially promised under Inspire and then just failed. And the amount of data which legally has to be in the public domain and factually is still either really blocked off or just hidden by obfuscation. I remember talking to the communications lady at the Austrian Environment Agency why one can't find the data. And we got in writing. They purposely hide it because otherwise people might find it. Then they might do something. That would be a problem. So, it is very purposely still being kept locked down. How do we address that level? Because, this is sort of the elephant in the room where we all claim that's been long solved. Not. And without that, everything else we do here just looks silly because the data there are so many gaps between countries. Each country puts up a different data set.
As an example, Kathy, the Inspire directive was out, and then there was a consultation on Inspire 2 called Green Data for All. which has never concluded. We don't know what is coming out of that. And there's some discussion about how does the commission respond to this? And in many cases, they pointed their finger at GREAT, which is the preparatory action for SAGE, to say, you give us the answers. And SAGE has the opportunity as a project to turn around to the commission and say, oh, by the way, we don't have access to A, B, and C. Where are those things? Why are they not part of SAGE? We could just report to that.
And
That's not going to fix the problem, but at least we can be a squeaky wheel. I personally, have great difficulty being a squeaky wheel, but somebody else will have to do that.
I mean, we need some squeaks, because otherwise we just keep pretending that it's all there, and we build elephants on elephants and wonder why it all crumbles.
Yeah, well, at least the common pretext to actually avoid contributing to Inspire, that was, ooh, what a complex data model you have built, I cannot follow, or I cannot transform my data to that, or citizen science will never reach this level. This is removed in the data space. I would like to clarify that. We have talked a lot about semantic interoperability, but we do not mean imposing a data model like in Inspire. And that will at least remove some barriers that are related to, I don't have enough money or staff to actually do this transformation. If they hide that on purpose, that's another story. I cannot answer to that. And the second thing that happened with Inspire is that despite the efforts, for instance, done in Catalonia to include universities, that failed miserably because there was no reward whatsoever, and it was complicated and long. So in the end, only the big administrators enter in the game that were actually the ones with the mandate of doing that. In the Green Deal data space, we try to be inclusive from the day ones. Kind of strange because we give the opposite feeling, no? Because we say, well, this is not open. But in the end, we are being inclusive. We are trying to allow companies to participate. We are trying to allow citizen science to participate. Of course, we do not exclude university data or whatever. So I believe that's an improvement from the Inspire situation. And, well, the rest we will see.